Hello everyone, this is a new chapter, chapter 10, classes and object-oriented programming. Now, this is probably the last new topic we are going to consider. Also, if this is the only information that you have about classes, that means you just scratch the surface and you probably cannot appreciate how important the classes are. Let's just say that if you are a software developer, you will most of the time or all the time either work with a class or work on a class, and most likely do both at the same time. So this is a kind of chapter where you want to pay attention whether or not you're going to be a software developer, but particularly so if you are a software developer, if you are in this program at BIPSI or elsewhere. So far, we looked at functions, and function was a very important abstraction for us. Instead of having 200 lines of code, one line after the other, we were able to group our code to perform a certain function and call one function after the other function in yet another function main. And that way, we were able to structure our code and we were able to debug each function separately before bringing them together in a main. And that made programming a lot easier. Now, as your project will get longer and longer, and by the way, I don't need you to use classes in your semester project in this class. I don't really feel that you'll be able to create diverse classes, and that's not a requirement. Oh, sorry, diverse objects, classes that allow for diverse objects. And in general, in the upcoming semesters, in the upcoming classes, you will see a lot more techniques and theory about the classes. I may be able to talk about hierarchy by the end of the semester, just a little bit. I won't be talking about coupling. I won't be talking about development patterns. Those are all topics for different classes. Those are topics that require extensive practice, extensive training, and let's say those for later. So definitely pay attention, and for now, it's just basic things what you can do with classes. So instance, in other words, an object is what you create the classes for. You can create multiple instances from a single class, and we will just a little bit talk about designing classes. All right, more about procedural programming, which is what we had so far. So procedures separate on data and return data, feed it into a next function, for example, and that's all they do. That's a lot, but that's not good enough for a major project. So we have been working with functions, and certainly I would expect you to work with functions for your final project. But there is a next level of abstraction. Functions are great. If you want your code to be super efficient, you might want to stick to functional programming, procedural programming, unless you know very well what you're doing with objects. But objects will allow you the next step. That is encapsulating together data and code, data and functions. So object is an entity that contains data and contains procedures. And data is known as data attributes or just attributes, and procedures are known as methods. Methods usually change the data in place. Some methods are private for inner working of an object. Some methods are public for somebody who is using an object or building on top of this object. This is a little picture about it. So data attributes inside an object and some methods. Those are, I would say, the private methods that allow you to change the object in place. Of course, we would want to also for this object to maybe interact with other objects or maybe just do some printing statements. So something should allow, some other methods should allow, or outside functions should allow to for this object to interact with uh, another with outside environment. You may have been wondering if we looked at objects before, and indeed we did. Pretty much everything, a lot of things in Python are objects. One of the objects that we worked before, we say created a list 1, 2. List itself is an object, and you create it in this way, and the attributes is 1 and 2. However, there is a lot more to the list than just a sequence with 1 and 2. First of all, when we print it, it's printed in this quite convenient way. And if we want to see what is inside list, we can do dir l. And list is actually an object. It's not just data, it's also a bunch of functions. Those are private methods that are in charge of inner workings of the list. And there are also public methods: append, clear, copy, extend, index, insert, and some other, that some of which we covered in previous chapter, some of them we did not cover. In any case, this is what we were working with, public methods, when we were manipulating lists. For example, in one of your homework problems, append and insert were very, very useful in the corresponding homework problem. About lists, I think about tiger fans. And here is the big picture. So somebody is creating a class and is taking care of the inner workings of the class using these methods. Also creating some public methods for us to use a class. And all we knew about the class is that it's a sequence of numbers and we can manipulate it using these methods. And also we were doing some indexing, and we had, for example, some functions that also return useful stuff about this class. So length of a list. That would be an example. The important part here is that we did not really look inside what kind of programming did they do in order to allow us to use lists, to define all these methods. Not just private methods. We did not look inside the how append is programmed, and you can do that, and obviously it is an open source information. You can get to it. However, as a user, you don't need to worry about this. You don't worry about these methods at all. Those are private, and all you need to know is how to use them, how to use the public ones that I'm highlighting right now. So yes, whether it is a list or a dictionary, it is an object from a class dictionary. So we have been working with some standard Python objects all the time. Now we want to understand something about how they work, and we want to create our own objects. So let me talk about creating a class. This is a class insect. In order to create it, we need double underscore, double underscore. This is a private method, init. So double underscore means private. This is telling Python how to create a class. The class has a self variable, the first variable in whatever method or variable or attribute you have that is referencing the object that will be created, and you get used to this and gradually understand it. So for now, don't worry if it doesn't make sense. What should make sense is that this insect comes with a name. This is the only attribute, and we're going to store it in self name for now, which has a name, which is equal to name. So this will be an argument you supply during the class creation. And this is telling the insect, the uh, this is saying that it will be created in this variable will be an attribute of this object. So I'm creating here two objects, fly1, which is insect with the name fly, another fly2, insect with the name fly, and also a spider object, spider1 object, insect with the name spider. So far, this is a very boring class. It doesn't really do anything. I'm going to run this code and play with it in the console. For example, I want to return fly1.name. So I want to return an attribute of fly1. That's the only attribute it has so far, and similarly I could return the only attribute we have for each of this. And maybe I'll show you a little tiny trick how to get insects interacting with each other. All right, so I created a public method now. So init is just initializing the object and supplying all the necessary arguments that will become class attributes. So self-name is an attribute now, self.name, and it's equal to the variable name that was currently it's a parameter, but when we do insect fly, the name is fly, and that is an argument which is fed into this attribute, becomes an attribute. Now, to make it interesting, I wrote a function, catch. This is a public method which we can call, and we will over here. Self, that is means that it's a method for the insect object that we will create. And there is another argument here, which is an insect object. So if insect object dot name, we're referencing the name of this parameter insect object is fly, and self name, here we're referencing the name of our current object is spider, then we print quota fly. Else if, for example, insect object, which is this argument dot name is fly and self name is fly, then two flies are playing with each other. So I created fly1 object and fly2 object and spider1 object, and now I'm spider1 catches a fly1. So when I run it, I would like to see that. Here we go. So spider caught a fly, and we can make it this printing statement a little nicer, but my point was you can make a meaningful method which can take arguments such as another object, and you can call, for example, the name of this object and compare it to the name of our current object, and depending on that, execute some code. So in our case, spider1 was an object that we created. We call spider1.catch on fly1. And to us, it means that spider1 catches fly1, and there is a corresponding code executing. I think this is a fun example. There are certain downsides of this example, and we are going to talk about them right now. So once you have created an object, you don't really want to do what I did previously, that is allow the program call on these attributes directly. They should be hidden for a variety of reasons, such as unintended changes and also conceptually object-oriented programming that is creating classes and then creating objects from these classes, you don't want to allow a user which creates an object from a class, or a programmer who creates an object from a class, accidentally supply some incorrect inputs and have like their own type of variable in the input. So you hide the actual attributes so that the person who is using a class cannot call them directly, and then you provide an interface, a getter or a getter to get a value of an attribute and setter to set the value of the attribute. So we also, besides data hiding, we want objects to be reusable so that an object can be used in different programs or called by different programs. For example, one person creates a class with some 3D image object, just a box, for example. And the other person is using this object to create a video game. So we want to, besides having an object with attributes and methods, we want some of those methods to have an output to interact with the code outside of the object. And what I was doing so far, just not hiding the attributes, was bad, and that way it's easy to interact, but also it's easy to corrupt. And we don't want to do that. Now let's think through an example of attributes, public methods, and private methods. Think about an alarm clock as an actual object, physical alarm clock. So what do we care about when when having an alarm clock? First of all, that it works, that it shows time, and we can set an alarm, we can snooze, we can switch alarm off, and that the alarm actually works as we intend for it to work. What we don't care about is how, maybe some of you do and actually disassembled an alarm clock and looked, but we don't have to care how the alarm clock is designed, what kind of electric circuits are used there, what kind of batteries or power is needed for it to work. So private methods is the inner workings of your alarm clock, and public methods are set time, set alarm time, snooze, and such. So we want to supply public methods for somebody who is going to use an alarm clock, and we don't necessarily want this person to meddle into how this alarm clock works is working inside. So class is like a blueprint for alarm clock or for an object we want to create. And instance is an object created from a class. The words object and instance will be used interchangeably. So let us actually, we will worry about how it's programmed and how to do it properly a little later. I showed you one example that's good enough for now. Now let's have inspirational examples and discuss what's going on. So you can create a blueprint for a house, and blueprint should describe what is a house, what kind of rooms are there. Maybe it should describe the water mains, the faucets, the shower, the heating, and a good blueprint would prescribe what kind of heating/air conditioning unit it requires. So you are creating a blueprint for everything that its house needs. This house will be. And from the same blueprint, somebody can build, different people can build different houses. And if your blueprint is good, it should allow for various people, families, single people, live in those houses. Your blueprint should allow for the house to be painted with different colors and to have different units of furniture inside. And that is actually, in this analogy, blueprint will be a class, And objects will be specific houses. You can build an entire neighborhood or entire country of houses from the same blueprint. Um, the difficulty of creating this blueprint, of creating a class, it should allow for enough diversity so that those houses are not exactly the same or don't allow for exactly the same number of people living in them or exact same furniture. So there should be provisions for some diversity among those objects created from the same class. And that's the difficulty. This is not the part that we're going to explicitly cover too much. There is theory and practice far beyond what we can cover in the remaining time. But I hope you are getting the importance of this concept of classes and objects. Another example is a cookie cutter. You can create cookies using the same cookie cutter. You can use different doughs or different color of sugar and whatever. But this cookie cutter determines something about your cookies. Also, it's important to know that cookie cutter does not contain any information about what cookies were made with it, what kind of dough was used. So it creates certain restrictions, it creates certain structure, the shape, but it does not know about any specifics of any of the hundreds of the cookies that were made from the same cookie cutter. Just like Blueprint does not care what kind of people live inside the house, whether they are messy, whether they paint their house in blue or green. And so Blueprint is an abstraction, and object is a specific house with specific attributes, like people who live inside it and the color of the house, and specific furniture that those people want to have in this house. We just talked about an insect class, and so you have seen an example. So the insect was a class, and in this class we can create objects like houseflies and mosquitoes. We could create some attributes. When creating an insect class, we could have more attributes such as number of legs of, say, housefly or mosquito, or number of eyes. Insects have different number of eyes if they do have eyes, or anything else like number of wings or shape of wings, as specific as you want to get. And as you've seen in example, this is how the class is defined. So keyword class and then class name with the first letter capitalized. Self parameter required in every method. References to specific object the method is working on, and it goes first. Self is itself is not a keyword in Python. Instead of self, you can use X, but you need to be consistent. And self is a commonly used word, and that's what you should do for referencing a specific object in every class. We did see the initializer method, double underscore, double underscore. All private methods have double underscore before and after, and please don't mess this up. And usually it's the first method in the class definition, as I had it in the first at first. So this is how you define a class. You define, for example, for a coin class, you will define a class in itself, and you choose a side of the coin just to be heads at the time of the creation. And side up will be an attribute of this particular object. For every object, there will be a fixed side up heads. To create an instance or to create an object, you do my instance equals to class name. And there go in parentheses all the all the variables that you want to have in your class. Let me actually go back to my example, loop back to my example. Oops, that's a different example. I already closed it, sorry. All right, so this is our init method. We are getting a variable name when we are creating every instance from that method. And we are creating an attribute of the class self-name equals to name. And in a better style, I would have to hide this attribute. I will do it in a moment. But so far, I'm not hiding anything. And as I was saying earlier, I have a public method cage with first variable self. It's referencing a particular object that will be created from this class. So fly1, self references fly1 for this object, fly2 for this object, and for spider, it just references itself. And this is another object which I'm taking as an argument of my catch function, and that object happens to be of the same class. So this is a private method, this is a public method. And I think that's good for the first example.